All right, so we're now moving on to the next part of this unit, which is 3D, and we're going to be solving and graphing absolute value inequalities. So we've already learned how to solve absolute value equations, and now we're going to apply what we learned there into an inequality to figure out, okay, well, what do we have to do in order to solve an absolute value inequality? All right, so what you'll have to know at the end of this video is you'll have to know how to solve absolute value inequalities. So make sure you come back to this and check and see, do I know how to do this? And make sure you come in class with any questions that you may have. All right, so we learned earlier in the year how to solve an absolute value equation. All right, we learned that when we have the absolute value of a number is equal to 5, well, we know that the absolute value of 5 is equal to 5, and we also know that the absolute value of negative 5 is equal to 5. So this actually generated two answers. We got that x was equal to 5 or negative 5. So when we had a question, and let's say I gave you a question, was the absolute value of 2x plus 1 is equal to 11. Well, when we were to solve this, we knew that we could have a positive or a negative number inside of our absolute value that would generate this 11. So we would set 2x plus 1 equal to 11, or 2x plus 1 is equal to negative 11, right? And we would solve each of these and would give us our answer. We will have to remember to do the both positive and negative when we do an inequality, but now that we have these inequality symbols that are greater than or less than, we now need to figure out, well, how do we apply those? What do we do with these inequalities when we're doing this, all right? So we'll see it's the same thought process of needing to generate this to be a positive and negative number, but now that we have these inequalities, we also need to think about, okay, what do we do with these and do we have to flip them at all? All right, so I just wanted to just talk about the equations first to remind us that it generated two answers, and we're still going to apply that for inequalities. So now we're going to talk about inequalities and absolute value, and what do we do in each of these scenarios, and then we'll solve an example. All right, so the first thing you have to remember is when we talk about the absolute value, that is the distance from 0. So when we're trying to graph this first one, the absolute value of x is less than 2. We're trying to figure out what are all of the numbers that we have where the distance from them to 0 is less than 2. So we know that we can go ahead and plot this first one of x is less than 2. Right? And we can go ahead and plot this here and start to go in this left direction because we know all these numbers here between 0 and 2 are less than 2 from 0. Right? Now, just like we did with our equation, we also need to think about this in terms of negative 2. So when we look at this negative 2 here, well, we need to see, okay, well, we want numbers that are less than 2 away from 0. So if we try to go in this direction, all of these numbers are actually further away from 2. So the only numbers that are closer than 2 from 0 are these numbers to the right. So you see here, in order for us to then now say, well, we want all these numbers going to the right of this negative 2, we need to change this inequality. It needs to go from less than to greater than. So because we're now looking on the opposite side of our number line, and remember, the smaller numbers in negative are actually greater. So when we see this less than here, it actually creates an end statement, right? And just think about it. Less than sounds like I'm saying the word end, and that's how you can remember it. Less than, it is an end statement. And what you do is you take exactly what's on the inside, so x, and then we set it exactly of the inequality that we had, just like we did with the equation. And then since it's less than, it is an end statement, and then we will go ahead and take our whatever is inside of our inequality, write it exactly like it is, and then we flip our inequality and we make the number negative. And you can also kind of remember that as well, because when we multiply both sides by a negative, we need to flip our inequality. And since we're dealing with the absolute value here, we know that it's going to make whatever number we have positive anyway. So if we were to try and multiply that by negative, it does nothing to it. But we can think about multiplying both sides by that negative and flipping our inequality just like we would if we were solving. All right, but to explain it, the reason why we have to flip is because we're saying the distance from this number needs to be less than 2 from 0. So in this case, in the positive number, we're going to the left, and that's why it's less than. But then when we flip over to that negative 2 and we start filling in what numbers are smaller or closer than 2 from 0, it is now greater than, because remember, the smaller numbers in negative are actually greater than. All right, so this will form an end statement. And the way that you can remember it is less than sounds like I'm saying the word end. All right, and now let's look at the other one. So the absolute value of x is greater than or equal to 3. So the first thing we'll do is we'll plot this greater than or equal to 3. So I go ahead, I color in a circle, and now greater than is going to the right. So remember, we're talking about the distance from 0. So we're looking to see, okay, on the other side, because now we need to have our x, let me put this in a different color. Now we need to compare it to a negative number. And now if we go ahead and put this on -3, we want numbers that are further away from 0 than -3. That means we need to go in this direction. And remember, on a number line, when we go to the left, that means we're going less than. And the bigger numbers are actually less than on the negative side. So once again, we need to flip this inequality, and it becomes x is less than or equal to -3. And this is an or statement. All right, so this one becomes or. So a way that you can remember this one, I'm going to change the way I'm saying the word here just a little bit, but greater, I'm going to stress that greater than, and it sounds like I'm saying the word or. So when we say less than, it sounds like I'm saying and, so we're generating an and statement. When we say greater than, it sounds like we're saying or. So it is an or statement. But the reason why it works, and the reason why we have to do this, is because we're dealing with how far away these numbers are from 0. And we want numbers, since the original problem said we want the numbers to be further away from 0 than 3, well, in a positive direction, it'll go in this direction here, so it's still greater than. And when we move to the negative, we need to flip our inequality because these numbers are actually less than now. All right, so the same thing. When we're doing this, we write whatever we have inside of our absolute value, and we write exactly like we have with our inequality. X is greater than or equal to 3. We'll have to identify, since it's greater than, it is an or statement. And then we write whatever was inside of our inequality, flip our inequality, and make it our negative number. All right, and we can remember kind of like we're multiplying both sides by negative or dividing both sides by negative, so that flips our inequality, or we're dealing with distance away from 0. And if we want our numbers to be closer to 0 than 2, well then when we move in our negative direction, it needs to go in the opposite of our positive because we know the bigger numbers are actually less than on the negative side. All right, now we're going to go ahead and solve just one problem using this, and then that'll be it for this video. All right, so let's go ahead and solve this problem. We're probably actually going to do 2 examples just so we can practice one of each type. But let's go ahead and solve this problem. So when we see the absolute value, I know it's going to have to generate 2 different answers. So right away, I'm going to take whatever is inside of my absolute value and write it exactly like it is, just the question, just removing the absolute value. Then I need to look at the absolute value symbol and say, okay, what type of statement is this going to generate? And since it's less than, it sounds like I'm saying the word and, so it generates an and statement. All right, so I know it's going to be x plus 7 is less than or equal to 2, and now I'm going to do the next one, which is x plus 7. So we write exactly what we have on the inside. We flip our inequality, it becomes greater than or equal to, and then we make it negative. So it creates these 2 different inequalities, and now we just need to go ahead and solve. So to solve for this, I'll subtract 7 from both sides and get x is less than or equal to -5, and then I'll go ahead and subtract 7 from both of these, and I get x is greater than or equal to -9. All right, remember, if you want to write this, this is acceptable of writing your answer like this. You must have that end. If you want to write it a different way, you can also say that -9 is less than or equal to x, which is less than or equal to -5. All right, or if you want to write it in interval notation, as we practice in class, we can say that -9 comma, since it is equal to, that means that we need to include it, so it's going to be a square bracket. So -9 comma -5, and since -5 is included as well, we can square bracket. So any one of these are acceptable writing your answer. Just if you do write it like this, make sure you include the word end. All right, now we're going to go ahead and graph. So x is greater than or equal to -9. So I'm going to fill in my number line here. We can count by whatever we want. So just to show you that we can count in different ways, I'm going to count by 2s. All right, I see both of these numbers are negative. So I'm going to go ahead and just write, I see that they're both odd. So I'm just going to start with a negative odd number. And I'm just going to go ahead and write all of these tick marks to just be counting by 2s. And that's perfectly fine. We don't have to count by 1s every time. All right, so now I'm going to go ahead and graph the first one. So x is greater than or equal to, less than or equal to -5. So here's my -5 as a colored in circle since it's equal to, and less than is going to the left. X is greater than or equal to -9. So here's my graph here at -9. I put the colored in circle, greater than or equal to going to the right. And remember, when we're dealing with an end statement, we need to see, well, where do they overlap? So they overlap here from -5 to -9, and that will be my final answer. All right, so that is it for this question. Let's go ahead and do one more with a greater than question. All right, and I also wanted to practice another one of these harder problems that we did do with equations, but just to remind us. So remember, for this problem, before we can go ahead and get started with anything, we need to isolate that absolute value all by itself. So I need to get rid of this -4 and this +1. So we do the same thing as we would have if we were inside this absolute value in solving. So we would get rid of the addition first. So I'll subtract 1 from both sides. So now that will give me, I'm going to write it over here, 4 times the absolute value of 2x minus 5 is greater than 28. And then I'm going to go ahead and divide each side by this 4 to isolate my absolute value. They cancel out. So now I'm left with the absolute value of 2x minus 5 is greater than 7. So remember, before you can get started with rewriting our two different absolute values, we need to isolate it first. And once we isolate it, we take whatever is on the inside. So we're going to say 2x minus 5 is greater than 7. So exactly what we have written here, but without the absolute value. Then we need to identify, is this an or an and statement? And I'm going to stress the way I say this, greater. So since it's greater, it is an or statement. So it's 2x minus 5 is greater than 7, or then we need to take what was on the inside again. We don't change that at all, 2x minus 5. Then we're going to flip our inequality, make it less than, and then we take the negative. So we are generating two different inequalities just like we did two different equations for absolute value. Then we just go ahead and solve each of them. So I'm going to add the 5 to both sides. So 2x is now greater than 12. Divide each side by 2. X is greater than 6. Or then I'm going to go ahead and add the 5 to both sides. So now 2x is less than negative 2. Divide by 2. Or x is less than negative 1. All right, once again, I'm going to make my number line a little bit different just to practice it. So I have even and odd number. I see that they're spaced out a little bit. So I'm just going to go ahead and plot my numbers by the even. So I'm just going to say negative 4, negative 2, 0, 2, 4, 6, 8, 10. There's different ways you can go ahead and plot this. And now I'm just going to go ahead and plot. The first one, x is greater than 6. So I'll put an open circle at 6. Greater than is going to the right. The next one, x is less than negative 1. So negative 1 will be halfway in between this negative 2 and 0. So I'll just plot that point there and draw my graph. Since it's an or statement, I just need to look quickly to make sure that they're not overlapping, that it's not a special case, and that will be my answer. Right? And the way that you can write your final answer is like this. Or if you wanted to write it in interval notation, we can go ahead and say that negative infinity to negative 1, and both of those are parentheses because we can't include them. We can use the union symbol, or you can write or if you want. And then we will go from 6 to positive infinity. So for this one, either one of these two highlighted could be an acceptable way of writing your answer. All right, and that is it for this video.